Welcome to a very short video on refrigeration and entropy. First, let's discuss how refrigeration works. And let's do this by examining the spontaneous process of energy being transferred as heat from a hot reservoir to a cold sink. So our hot reservoir is at some temperature TH. As energy leaves the hot reservoir, dQ, goes into our cold sink at temperature Tc. The hot reservoir decreases in entropy, so that's this arrow going down. The entropy is decreasing for the hot source as the temperature of the hot source decreases. Because if we're pulling heat out of the hot source, then the temperature must be decreasing. And that means that the entropy is decreasing. But the cold reservoir is increasing in energy because the temperature there, increasing in entropy as the temperature is increasing. As we're adding heat into the cold sink, the temperature of the cold sink is rising, and that means that the entropy must be rising. Furthermore, the increase in entropy of the cold sink is larger than the decrease in entropy in the hot source. So, if we examine the transfer of energy in a refrigerator, transfer of energy as heat in a refrigerator. In the refrigerator, we transfer energy as heat from a cold reservoir up into our hot sink. Note that it doesn't have to be up, but we're transferring that energy from the cold source into the hot sink as heat. So, what happens to the temperature of the cold source? It gets cooler. The temperature of the cold source decreases, the temperature of the hot sink increases, and this means this process is non-spontaneous because the entropy of our cold source is decreasing as the temperature drops, the entropy drops, so we have a large decrease in entropy. For that same heat transfer into our hot sink, we have a smaller increase in entropy. We're increasing the entropy because we're increasing the temperature as we add heat. But remember that objects at higher temperature, systems at higher temperature, have smaller changes in entropy than systems at colder temperatures. So this is why the entropy change for our cold source is larger, is a larger negative value than our entropy change for our hot sink. So, if this is true, then the overall entropy change, if we don't do anything else, is negative. Because the entropy of our cold source is decreasing by more than the entropy of our hot sink is increasing. So this would be a non-spontaneous process. If you put something cold next to something hot, the hot object doesn't increase in temperature and the cold object decrease in temperature. The opposite is spontaneous. So, in order to get this to go, we have to put in energy as as work. So, we must input energy as work to the hot reservoir. We've got to also put in some work in order to get the hot reservoir, the entropy change of that hot reservoir, to be at least as large of a positive value as the entropy change of our cold source is a negative value. Right, so I've shown that over here. We now have some work going in. The addition of this work plus the heat to the hot sink must cause an increase in entropy that is at least as large as the entropy decrease in our cold sink. So, we're inputting energy as work into our hot sink, and that means that we have to do work to have a refrigerator.